This is the platform that we had established some time ago, and that has allowed us to discover a number of molecules, not just against Parkin ligase that I'm going to talk about, or another ligase that degrades KRAS protein, but also a number of other ligases that we have published in the past. The platform is composed of a variety of assays. We have activity assays like E1, E2 enzyme, and E3 enzyme. These are FRET-based or ELISA-based assays. You can go to the website and learn more. We combine the compounds we discover. We then characterize them through biophysical screen. That could be SPR or NMR. We primarily use thermofluor and SPR that we have in our labs to look at the small molecule target protein interaction. There are, of course, binding studies, protein-protein interaction, protein small molecule interaction. And then it's terribly important to have PD markers. So if you show that the compound is ubiquitinating a target in the cell, that you should be in a position to demonstrate the type of ubiquitination, the nature of the ubiquitin chain, and then of course the half-life of the protein. And this is all done in the cell or in the target tissue or in the animal tissue, or in this case human tissue, capturing the tissue, demonstrating drug-mediated ubiquitination. That is the biomarker. Discovered a ligase that is associated with the membrane, and we asked the question, does it degrade membrane receptor more efficiently than the cytosolic protein or nuclear protein? Okay, well, I like to show you. These are, of course, the tyrosine kinase receptor, and you know, there are famous drugs, HER2, NU2, EGF. These are oncology drugs, including JAK and c-MET and so on and so forth. The other evidence that is interesting is that human mutations in Parkin ligase leads to early onset of Parkinson's disease. Understandable. If you don't have active Parkin, dopaminergic neurons that are very susceptible to the damage of mitochondria because they're making so much dopamine, they need to be repaired, and a mutation in Parkin cannot repair it. You come down with early onset of Parkinson's disease. Mutation in pink kinase also lead to early onset of Parkinson's disease. So it seems ubiquitin proteasome system plays a very intimate role in managing mitochondrial health. So not only Parkin ligase gets rid of damaged mitochondria by mitophagy or autophagy, but it also turns on nuclear mitochondrial gene. You can't get rid of damaged mitochondria if you don't make new mitochondria. So Parkin ligase goes into the nucleus, degrades a repressor called Paris, and that repressor gone, then PGC1, which is a global transcription factor, turns on all the mitochondrial gene. You have a new mitochondria. Okay, so this is a fantastic, really a system built by nature. So I give you some examples of that. So remember, I said the damaged mitochondria alter protein kinase, which becomes active, and then it comes out and phosphorylates Parkin. So pink phosphorylate Parkin, phosphorylated Parkin becomes active, and it starts making polyubiquitin chains. These chains are attached to mitochondrial protein, leading to mitophagy, as well as mitobiogenesis, and you have new mitochondria, and your neuronal health is improved.